This is Holly Uso with the math lesson.
So here we have four different graphs, and we'd like to know, do each of these graphs represent a function? Well, the way that we can tell if a graph represents a function is if any vertical line crosses the graph at most once. So if we imagine this extends farther in both directions, infinitely far up and infinitely far down, will this cross over this graph more than once? At each moment, for each one of these lines, it will cross the graph at most once. Thus, this is a function. It passes the vertical line test. Note that this graph does not represent a function, because here, this vertical line crosses the graph 2 times. Thus, for the function value, or for the relation value of x is 1, when x is 1, then y could be 1, or y could be -1. Thus, this does not represent a function. Is this a function? Yes, passes the vertical line test. We'll call that VLT, vertical line test. Does this graph represent a function? No. A vertical line intersects the graph 2 times when we draw a particular one. We can pick any one we like, so if we can find just one that crosses it more than once, then boom, it fails the vertical line test and fails to be a function. Because when x is 1, y could be 1 or could be -1, and that is not a function. Each x has to give us one y, and that y will not change for that particular graph. Sometimes these graphs that are not functions are called relations. What about this graph? Does it represent a function? I'll give you just a minute to think about it. Think about a vertical line. Can you draw one that hits it more than once? I bet you can. Here's one. This does not represent a function because a vertical line will intersect the graph more than once. What about this graph? Is this a function? Yes. Because any vertical line that you draw will intersect the graph, but at most once. So there are no x values. It sometimes gives you one y and sometimes give you another one. This one passes the vertical line test. All right, good job, class. Now, what if instead of having the graph, we had the equation of each of these functions? Well, if you have an equation, then you have to be able to tell whether the graph or whether the equation represents a function or a relation. Sometimes it's easy to tell. So for example, this would be the graph of y equals the absolute value of x minus 2. Since y, for each x that we put in, we're only going to get out one y, this one will pass the vertical line test. The same thing is true for this graph. This is the graph of y equals 4 minus x squared. Any x we put in, we're going to square it, subtract it from 4, we're going to get one value of y, and thus this passes the vertical line test. But what about the circle? Well, if we have x squared plus y squared equals 4, and we solve this for y squared, we get this. Now, if you have y squared equals an expression, the chances are that that's not going to be a function. If it were equal to 0, that's about the only exception. Because if y squared equals 4 minus x, then that means that either y could equal to 4 minus x squared, if you take the square root of all that, or y could equal minus 4 minus x squared. And that is going to give us more than one option for y, for many of the x values that the function is defined for. And a similar thing can be said about the sideways parabolas. So, if we are looking at an equation of a graph, how can we tell just from the equation if it's a function? All right, class, so let's consider these equations and see, are they functions? If the y value can be more than one thing given a particular x, then it's not going to represent a function. So here, since absolute value of y is x plus 1, that would mean that if we put in, let's say, x equals 3, then either y equals 4 or y equals minus 4 would satisfy that. And thus we'd have one x value of 3 going to more than one y value. So this would be a no. What about this? X squared is y plus 1. Well, this is just a parabola that opens up, and a vertical line will pass through it exactly once. One way to think about this is that while it is true that the x is squared, the y is not squared. So this one does represent a function. Will pass the vertical line test. Y squared equals x minus 2. Let's look at equation C. Well, if y is squared, then y would equal plus or minus square root of this thing. That's not going to be a function because you could put in one value for x and get two different values for y a lot of the time. And what about equation D? Y equals 3x plus 4. This is just a slanted line.
This is the graph of y equals negative 3x plus 4.
So it is going to pass the vertical line test and be a function. So a lot of students kind of see some commonalities here. If the x is squared, that's okay. If the x has the absolute value around it, that's okay. But if the y is squared or the y has the absolute value, that will mean when we put in our x, we could get more than one possibility that would satisfy our equation for y. And that is when the equation does not represent a function. Good job, class.